Take a deep, slow breath in. Feel the air as it moves past your lips, cooling the back of your throat and filling your lungs with a steady, rhythmic expansion. As you exhale, let your shoulders drop. Feel the weight of your body pressing against the surface beneath you. Imagine that surface is not just a bed or a chair, but the very skin of the earth itself. You are supported by miles of ancient stone, held firmly by the gentle, constant pull of gravity. As you breathe out again, imagine your tension dissolving like salt in warm water. Let your awareness begin to sink. We are leaving the world of light, wind, and movement behind. We are traveling downward, through the soft, damp loam of the forest floor, past the tangled web of tree roots and the cool, dark burrows of sleeping creatures. We are moving into the bedrock, the foundational bones of the world. Here, the air changes. It becomes still, thick with the scent of wet stone and ancient minerals. It is a quiet that has existed for millions of years. This is the lithosphere, the rigid outer shell of our planet, and as we descend, you may feel a sense of profound safety. You are being cradled in a cocoon of solid earth, far beneath the noise of the surface. As we settle into this subterranean realm, notice the temperature. It is not cold here. In fact, for every kilometer we descend into the Earth's crust, the temperature rises by approximately 25 degrees Celsius, or about 77 degrees Fahrenheit. This is known as the geothermal gradient. This gentle, rising warmth is the heartbeat of the planet, a slow-burning heat left over from the Earth's formation and the steady decay of radioactive elements deep within the core. Feel that warmth radiating around you, a soft, heavy heat that relaxes your muscles and soothes your mind. You are now standing in a vast, hidden cathedral of stone. It is a vug, a natural cavity or pocket inside the rock. Most people imagine the underground as a solid, cramped space, but the earth is porous, filled with secret chambers and veins. In this chamber, the air is humid and heavy, tasting faintly of iron and salt. There is no wind here, only the slowest, most deliberate movement of water. Listen to the sound of the deep earth. It is not a silence, but a low-frequency hum, a vibration that occurs between 0.1 and 10 hertz, far below the range of human speech. It is the sound of tectonic plates grinding at a microscopic pace, the sound of the planet breathing. It is a deep, resonant bass note that vibrates in your chest, grounding you, anchoring you to this moment. Look around this dark chamber. As your inner eyes adjust, you begin to see a faint, ethereal glow. This isn't sunlight. It is the subtle luminescence of minerals reacting to the pressure of the earth. In front of you, emerging from the rough, dark walls of the cavern, are the crystals. Here is something most people don't know. Crystals are not just rocks. They are the ultimate expression of order in the physical universe. While most matter is a jumble of atoms, a crystal is a perfectly repeating geometric lattice. Every atom of silicon, every molecule of oxygen, is locked into a precise mathematical position. It is as if the Earth, in its deep silence, decided to compose a symphony out of solid matter. To your left, a cluster of quartz points emerges from the wall. Quartz is the most common mineral in the Earth's crust, composed of silicon and oxygen, the two most abundant elements, which together make up about 74% of the crust's total mass. These particular crystals are clear as mountain water, their six-sided faces polished to a mirror shine by the slow passage of time. Reach out in your mind and touch the surface of a quartz point. It is surprisingly smooth, feeling almost like frozen liquid. It is hard, yet strangely energetic. What's fascinating is that quartz is piezoelectric. This means that under the immense pressure of the rock layers above us, pressure that can reach hundreds of times the atmospheric pressure at sea level, actually generates a tiny electric charge. When you touch it, you are touching the literal energy of the Earth, converted into a silent, steady pulse. The growth of these structures is a process of incredible patience. These crystals do not grow like plants. They precipitate. Deep underground, water is not just a liquid, it is a powerful solvent. Superheated by the magma chambers miles below us, this water becomes hydrothermal fluid. As it moves through the cracks in the rock, it dissolves minerals, carrying atoms of gold, silver, copper, and silica in a warm, rich soup. As this fluid enters this cool, quiet chamber, it begins to slow down. The temperature drops just enough for the water to become supersaturated. This is the moment of nucleation, the birth of a crystal. A single atom of silica finds a tiny imperfection on the cave wall and latches onto it. Then another follows, and another, following the strict laws of chemistry to build a lattice. Think about the timescale of this growth. A single large crystal in this cave might grow at the rate of a few millimeters every 1,000 years. To reach the size of a human hand, it may have sat in this exact spot, in this exact silence, since before the first civilizations rose on the surface. While empires fell and forests grew and died above, this crystal remained here, slowly adding one atom at a time, layer by microscopic layer. Notice the texture of the cavern floor. It is covered in a fine, crystalline sand, the seedlings of future giants. The floor is slightly damp. This moisture is vital. For a crystal to grow perfectly, it needs space, and it needs a constant, steady supply of mineral-rich water. If the water flows too fast, it erodes the crystal. If it stops, the growth freezes. Here, the flow is a perfect, rhythmic drip, asterisk, drip, pause, drip, asterisk. Each drop carries a microscopic tribute of mineral wealth to the growing lattice. Directly in front of you, a magnificent pillar of selenite, a variety of gypsum, rises from the floor. It is translucent, like a column of moonlight. Selenite is famous for its ability to grow to massive proportions. In places like the Nika mine in Mexico, these crystals have reached lengths of 36 feet and weights of 55 tons. Here in our hidden chamber, the selenite pillar is warm to the touch. This is because gypsum has a low thermal conductivity. It holds onto the Earth's internal heat, feeling almost like a living thing. As you run your hand along its side, you notice it isn't perfectly smooth. It has long, vertical striations, like the strings of a harp. If you were to tap it, it would ring with a dull, resonant thud, the sound of a mineral that is actually quite soft, only a 2 on the Mohs scale of mineral hardness. You could scratch it with your fingernail, yet it has stood here for eons, undisturbed by the winds or the rains of the upper world. Observe the inclusions trapped inside the crystal's body. These are tiny bubbles of water or gas that were caught inside the lattice millions of years ago. They are primordial fluid inclusions, tiny time capsules. The water inside that bubble hasn't touched the atmosphere in 10 million years. It is pure, ancient, and still. Looking at it, you feel a sense of profound stillness. Your own breath begins to match the slow, geological pace of the cavern. There is a smell here, too. It is the scent of petrichor, but intensified. Petrichor is usually associated with rain hitting dry earth, but its source is the oils secreted by plants that are absorbed by the minerals in the soil. Down here, that scent is combined with the sharp, clean smell of ozone and the heavy, sweet scent of sulfur from the deep volcanic vents. It is the smell of the Earth's laboratory, the place where the very ingredients of the world are being refined and organized. The colors in this chamber are muted, but rich. There are deep ochres, burnt oranges from iron oxides, and the pale, ghostly violets of amethyst, a variety of quartz that gets its color from gamma irradiation and trace amounts of iron. The light seems to come from within the stones themselves. It is a soft, diffused glow that doesn't cast harsh shadows, creating an environment of soft edges and total peace. As you stand in this chamber, you realize that you are part of this cycle. The minerals that make up these crystals, calcium, sodium, potassium, are the same minerals that flow through your blood and strengthen your bones. You are not a visitor to the earth. You are a piece of the earth that has been given eyes to see its own hidden beauty. The pressure of the miles of rock above you doesn't feel heavy. Instead, it feels like a weighted blanket, a comforting pressure that tells your nervous system it is okay to let go. Deep in the crust, there are no storms. There is no wind to chill you, no sun to burn you. There is only the steady, rhythmic pulse of the geothermal heat and the slow, inevitable growth of the crystals. You find a smooth, flat ledge of basalt near the center of the chamber. It has been polished by ancient underground rivers until it feels like silk. You lie down, the warmth of the stone seeping through your clothes and into your spine. Above you, the ceiling of the vug is encrusted with tiny, sparkling druzy quartz, thousands of tiny crystals that look like a galaxy of fallen stars. As you lay there, you realize that time here is different. Minutes, hours, and years are meaningless to the stone. There is only the long, slow now. The drip of the water, the hum of the earth, and the silent expansion of the crystal lattices. You are safe. You are deep within the cradle of the world. The air is perfect. The warmth is constant, and the silence is a gift. As we prepare to journey deeper into the life of these stones in the next part of our journey, feel yourself sinking further into the basalt. Your heartbeat slows, matching the 0.1 Hertz frequency of the planet. You are grounded. You are still. You are becoming part of the mountain. The journey has only just begun, but for now, there is nothing to do but breathe. Listen to the drip of the mineral-rich water. Feel the ancient heat. Observe the silent, geometric perfection of the quartz and the selenite. You are settling into the natural world, far beneath the surface, where the only thing that grows is beauty, and the only thing that moves is time. Breathe in the scent of the deep earth. Let the darkness be a soft velvet curtain around your mind. You are exactly where you need to be. You are resting in the heart of the world, and the crystals are watching over your sleep, growing atom by atom, eon by eon, in the beautiful, golden dark. Resting here on this smooth, obsidian dark ledge, you are surrounded by a silence that is almost tactile. It is a heavy, velvet quiet that feels like a physical embrace. This basalt beneath you was once a river of fire, surging at temperatures exceeding 1,100 degrees Celsius, or 2,000 degrees Fahrenheit, before it cooled into this dense, supportive foundation. As you lie still, consider how humanity has struggled for millennia to understand the slow, patient magic of the stones around you. For much of our history, The origin of these geometric wonders was a source of profound mystery. Consider the ancient Greeks, who first named the clear quartz you see glinting in the cavern walls. They called it kristallos, which literally translates to ice. They held the firm belief that these stones were not minerals at all, but water that had been frozen so intensely by the weight of the mountains that it had lost the ability to melt. It wasn't until the 17th century that we began to grasp the true nature of their birth. In 1669, a Danish scientist named Nicolaus Steno made a breakthrough that changed our understanding of the Earth forever. He observed that regardless of a crystal's size or where it was found, the angles between the corresponding faces were always identical. In quartz, those angles are always exactly 120 degrees. This is known as Steno's law of constancy of interfacial angles. And it was the first clue that nature operates on a hidden, mathematical blueprint deep within the soil. Picture the atoms inside the crystal lattice as guests in a grand, silent hotel. At this very moment, millions of atoms are checking in, finding their precise, assigned rooms in the structure. They don't arrive in a chaotic rush. They move with a dignified geological pace. In some environments, like the deep-seated pegmatites where giant beryl crystals grow, it can take over 100,000 years for a single crystal to reach its full size. This is a pace of life that makes the passage of human centuries look like the blink of an eye. Notice the air around you again. It carries a faint, metallic tang, the scent of oxidation. This is the same chemical process that causes iron to rust on the surface, but down here, it works with exquisite subtlety. Scientists have discovered that some of the most vibrant colors in these caverns come from the tiniest of impurities. What's happening now is a form of natural alchemy. A clear crystal of beryl becomes a deep, lush emerald simply because a few atoms of chromium or vanadium have replaced the aluminum in its structure. If iron atoms take those places instead, the crystal turns the pale, oceanic blue of an aquamarine. These trace elements are often present in concentrations of less than 1%, yet they define the entire visual character of the stone. Transition your gaze to the bands of color on the far wall, where an agate has formed inside a hollow pocket of volcanic rock. These pockets are called amygdules, from the Greek word for almond. When gas bubbles were trapped in cooling lava millions of years ago, they left behind these smooth, oval cavities. Over thousands of years, silica-rich groundwater seeped into these bubbles, depositing microscopic layers of chalcedony. Each band represents a different pulse of the Earth, a change in the local chemistry, or a shift in the temperature of the water. Some agates have over 10,000 individual layers per inch of thickness. Each line is a heartbeat of the mountain, a record of a season that lasted 1,000 years. At this very moment, deep beneath where you are resting, perhaps 150 kilometers or nearly 100 miles further down the Earth, is performing its most high-pressure miracle. This is the realm of diamond formation. Diamonds are created in the diamond stability zone within the Earth's mantle, where the pressure is a staggering 50,000 times greater than the pressure at the surface. Here, the temperature hovers around 2,200 degrees Fahrenheit. In this environment, carbon atoms are squeezed so tightly together that they form the strongest chemical bonds known in nature. What's fascinating is that these diamonds only reach the surface through rare, violent volcanic eruptions called kimberlite pipes, which travel at supersonic speeds to bring these treasures from the deep mantle to the crust. But here, in our quiet cavern, the pressure is just a gentle, constant weight, keeping everything in its perfect place. Think back to the year 1880, when two brothers, Jacques and Pierre Curie, were experimenting with these very stones. They discovered a phenomenon that had been happening in silence for billions of years: piezoelectricity. They found that by applying mechanical pressure to a quartz crystal, they could produce a measurable electric voltage. This is because the crystal's internal structure is so orderly that pushing on it actually shifts the balance of ions, creating a pulse of energy. The stone you are looking at isn't just a static object. It is a potential battery, a silent generator hummed into existence by the weight of the world. There is a specific kind of stone nearby that catches the faint internal light of the cave, a cluster of purple fluorite. It has a soft, cubic structure, like a collection of tiny, frosted dice. In 1852, a scientist named George Gabriel Stokes noticed that this mineral had a strange property. It would glow when exposed to invisible ultraviolet light. He named this phenomenon fluorescence, after the mineral itself. In the darkness of this cavern, the fluorite may be absorbing tiny amounts of energy from the surrounding rock and re-emitting it as a soft, ethereal glow. It is the Earth's own way of lighting its secret galleries. As you breathe in the cool, mineral-heavy air, consider the sheer age of the materials surrounding you. In the Jack Hills of Western Australia, scientists discovered tiny crystals of zircon that are 4.4 billion years old. To put that in perspective, the Earth itself is only about 4.5 billion years old. These zircons are the oldest solid fragments ever found on our planet. They have survived the tectonic shifting of continents, the rising and falling of mountain ranges, and the birth of the first oceans. They are the ultimate witnesses to history. When you touch the stone beside you, you are touching a lineage of matter that stretches back to the very dawn of time. Notice how the historical understanding of these stones has always been a blend of utility and wonder. Take, for instance, the deep blue lapis lazuli. The Sarisang mines in Afghanistan have been producing this stone for over 6,000 years. It was one of the first gemstones ever traded, making its way across the ancient Silk Road to the pharaohs of Egypt and the artists of the Renaissance. This mineral isn't just a crystal, it is a bridge through time, connecting the hands of an ancient miner to the eyes of a modern observer. Deep within the silence, you might notice a very faint rhythmic sound, a slow, resonant thrum. This isn't your imagination. It is the Schumann resonance, a set of spectrum peaks in the extremely low-frequency portion of the Earth's electromagnetic field. While these are usually associated with the atmosphere, the minerals in the crust act as a massive resonator for these pulses. The quartz, the feldspar, and the mica are all vibrating in sympathy with the planet's natural frequency of 7.83 Hz. As you lie here, your own heart rate begins to synchronize with this deep terrestrial rhythm. You are being tuned by the mountain. The history of crystallography is also a history of human light. Before we had the technology to grow our own crystals for watches and computers, we had to find them here, in the dark. During the early 20th century, crystal hunters would spend weeks in the silence of deep mines, following vugs or veins of ore. In 1910, miners in Nyaca, Mexico, broke through a wall and discovered the Cave of Swords, a chamber filled with gypsum crystals that looked like giant, translucent blades. They spoke of the air being so hot and humid that they could only stay for a few minutes at a time, a stark contrast to the comfortable, heavy warmth you are experiencing now. Every crystal here has a habit, the characteristic shape it takes based on its environment. Some grow as needles, others as blades, rosettes, or pyramids. This is determined by the unit cell, the smallest repeatable group of atoms. Imagine a single brick that, when stacked, can only ever form a specific type of cathedral. The habit of the stone is its destiny, written into its very atoms from the moment of nucleation. As you prepare to move deeper into the sensory world of the minerals in our next part, let your mind rest on the idea of inclusion. Look closely at a clear piece of quartz nearby. Inside, you see tiny, hair-like golden threads. These are crystals of another mineral rutile that were swallowed by the quartz as it grew. This is known as rutilated quartz. The rutile formed first, and the quartz simply grew around it, preserving the delicate threads in a tomb of glass. It is a moment of prehistoric time, frozen in a perfect, solid embrace. You are like that rutile thread now safe, protected, and encased in the vast, solid piece of the earth. The pressures of the world above cannot reach you here. The history of the earth is not a story of chaos, but a story of slow, magnificent order. Each atom finds its place. Each crystal finds its shape, and you, lying on this warm basalt, are finding your own state of perfect, undisturbed rest. The darkness is your protector, the stone is your bed, and the slow, rhythmic heartbeat of the earth is your lullaby. Continue resting your weight against that cool, silk-smooth basalt. As you breathe, notice how the air in this subterranean chamber feels incredibly filtered and clean. This is because the surrounding rock acts as a natural sieve, stripping away the dust and pollen of the surface world. You are inhaling air that is fundamentally pure, oxygen that has been held in the Earth's lungs for decades. Observe the rock wall directly beside you. It isn't a flat, uniform surface. Instead, it is peppered with small, dark red stones embedded deep within the grey matrix. These are almandine garnets. At this very moment, try to imagine these garnets not as static rocks, but as the result of a slow-motion kitchen miracle. Scientists often compare the formation of these crystals to the way raisins are distributed within a loaf of baking bread. This process is called metamorphism. The surrounding rock, or dough, was subjected to immense heat and pressure enough to make the minerals soft and pliable, but not enough to melt them into liquid. In this state, atoms of iron, aluminum, and silica migrated through the solid rock, clustering together to form these perfect 12-sided dodecahedrons. Just as a raisin occupies its own space in a muffin, these garnets grew by pushing the surrounding atoms aside, creating a gemstone that is actually harder and denser than the rock that houses it. Shift your focus to a small, translucent sheet of mineral leaning against the cavern wall. This is muscovite, a common form of mica. Reach out and imagine the sensation of running your thumb along its edge. It feels like a stack of incredibly thin, flexible plastic. Mica has what geologists call perfect basal cleavage. Picture a deck of playing cards held tightly together. You can easily peel the top card off the deck, but it's nearly impossible to tear the entire deck in half at once. Mica is built exactly like that. Its atoms are bonded strongly in two-dimensional sheets, but the bonds between those sheets are very weak. In the 18th and 19th centuries, before the advent of tempered glass, people used large sheets of this mineral, often called Muscovy glass, for oven windows, because it could withstand the intense heat of a fire without cracking. It is a natural laminate, a prehistoric version of the safety glass we use today. Further along the cavern floor, you might see white, crystalline cubes that look remarkably like oversized dice or sugar cubes. This is halite, better known as common salt. What's happening here is a demonstration of nature's love for the cube. In a halite crystal, every sodium atom is surrounded by 6 chlorine atoms, and every chlorine atom is surrounded by 6 sodium atoms. This 1-to-1 ratio creates a perfect, repeating cubic lattice. If you were to take a hammer and crush one of these large cubes, it wouldn't shatter into random shards. Instead, it would break into thousands of smaller, perfect cubes. This is the habit of the mineral, its geometric destiny. Even at the microscopic level, salt is always trying to be a box. It is one of the few minerals that humans can actually taste, a bridge between the geological world and our own biology. Consider the concept of mineral hardness. Scientists use a tool called the Mohs scale to categorize everything from the softest dust to the hardest gem. At the very bottom of this scale, with a rating of 1, is talc. If you were to hold a piece of raw talc in your hand, it would feel oddly greasy or slippery, much like a dry bar of soap. It is so soft that you can easily scratch it with your fingernail, which has a hardness of about 2.5. At the other end of the spectrum is the diamond, with a hardness of 10. To understand the difference, imagine the atomic bonds in talc are like pieces of wet tissue paper, easily torn apart, while the bonds in a diamond are like interlocking steel beams. This range of textures provides the grain of the underground world, a tactile variety that keeps the Earth from being a uniform mass. Notice a clear, rhombohedral crystal nearby that looks like a slanted box. This is Iceland's spar, a variety of calcite. If you were to place this crystal over a written word, you would see that word twice. This phenomenon is called double refraction or birefringence. What is occurring is that the crystal's internal structure is so specific that it actually splits a single beam of light into 2 separate paths as it travels through the stone. For the Vikings, this sunstone was a vital navigational tool. Even on an overcast day, they could use the double refraction of the calcite to locate the sun's position in the sky, allowing them to cross vast oceans without a compass. It is a piece of ancient technology, a lens crafted by gravity and time. Looking at the ceiling of our chamber, you see several rounded, lumpy rocks that look like dusty, unappealing potatoes. These are geodes. A geode is essentially a hollow bubble in the earth that has been lined with a secret treasure. Picture a basketball that has been buried in the soil for 1,000,000 years. Over time, mineral-rich water seeps through the porous outer shell, depositing tiny crystals on the inside of the ball. Slowly, the walls grow inward, layer by layer, like the rings of a tree. A geode that looks like a plain, brown rock on the outside might contain a hollow cathedral of deep purple amethyst or sparkling white quartz on the inside. It is one of nature's most effective ways of gift wrapping its beauty, keeping it safe from the elements until the moment it is finally cracked open. Now, imagine picking up a small, dull gray stone near your hand. This is galena, the primary ore of lead. You would expect a stone of this size to be light, but as you lift it in your mind, your wrist dips. Galena has a very high specific gravity. It is roughly 7.6 times denser than water. To put that in perspective, picking up a piece of galena feels like picking up a suitcase that you thought was full of clothes, only to find it has been filled with lead weights. This density comes from the heavy lead atoms being packed incredibly close together. It is a reminder that the underground world is not just about light and beauty. It is also about the raw, physical weight of the elements that build our cities and power our technology. Observe a curious formation on the far ledge, 2 dark brown crystals that have grown together in the shape of a perfect cross. These are starolite crystals, often called fairy crosses. This happens through a process called twinning, where two separate crystals share some of the same atoms in their lattice. It's as if two houses were built so close together that they shared a single wall and a single chimney. In starlight, the crystals usually cross at 90 or 60 degrees. This isn't an accident or a carving. It is the result of the atoms finding the path of least resistance as they grow under the immense pressure of the Earth's crust. Deep within the stone beneath you, there is a subtle change occurring. There are certain minerals, like hackmanite, that possess a quality called tenebrescence. Scientists have found that these stones can actually change color when exposed to different types of light. If you were to bring a piece of hackmanite to the surface, it might appear pale pink, but after sitting in the dark for a long time, it fades to white. It is a reversible photochromism, similar to the way some eyeglass lenses darken in the sun. Down here, in the permanent twilight, these minerals are in their most relaxed state, holding onto their true, unadulterated essence. Everything in this environment is interconnected through the movement of fluids. Picture the plumbing of a giant house. The pipes are the cracks and fissures in the rock, and the water is a hot, mineral-rich brine. This brine doesn't just sit still. It circulates in massive loops called convection cells. As the water is heated by the deep magma, it rises, dissolving minerals as it goes. When it reaches these cooler upper chambers, it sinks, leaving behind the crystals we see. This is the Earth's circulatory system, a slow, warm pulse that ensures the nutrients of the mineral world are always being redistributed. The heat you feel against your back is part of this system. It is a gentle, radiant warmth, like the heat from a terracotta pot that has been sitting in the sun. This temperature stability is why many of these crystals are so perfect. On the surface, temperatures fluctuate wildly between day and night, summer and winter. But here, the temperature may not have changed by more than a fraction of a degree in 10,000 years. This thermal stillness allows the atoms to take their time, ensuring there are no flaws or cracks in the crystal lattice. As you continue to lie on the basalt, allow the heavy, mineral-rich atmosphere to press gently against your skin. You are surrounded by a world that operates on a logic of geometry and patience. The raisins of garnet, the playing cards of mica, and the sugar cubes of salt are all around you, silent and growing. The pressure of the earth is not a burden, it is the sculptor's hand, shaping the chaos of the elements into the order of the gem. You are safe in this laboratory of time. The air is still, the warmth is constant, and the stones are ancient. As we prepare to move into the next phase of our journey, feel your body becoming even more relaxed, sinking into the soft, velvet dark. The rhythm of the dripping water and the low hum of the earth are the only sounds in this vast, quiet gallery. You are a guest of the mountain, and for now, the mountain is content to let you rest in its sparkling, silent heart. Allow the weight of your body to settle even more firmly into the dark, warm basalt. As you breathe here, in the silent heart of the mountain, consider the profound truth that you are not merely a visitor in this crystalline world. You are, in a very literal sense, a biological extension of it. While we often think of crystals as cold, distant objects of the deep earth, the very same chemistry that builds the quartz and garnet around you is currently at work inside your own body. Think of it this way. Your skeletal structure is a masterpiece of biomineralization. At this very moment, your body is maintaining a crystalline lattice of calcium phosphate, specifically a mineral called hydroxyapatite. These microscopic crystals are what give your bones their strength and durability. Within the quiet sanctuary of your own being, Your cells are acting as tiny subterranean masons, constantly depositing and refining these mineral structures. Just as the Earth builds its foundations over eons, your body is a living gallery of mineral growth. You are a bridge between the biological and the geological. Submerging further into the quiet, look toward the corner of the cavern where a faint, metallic sheen catches the soft internal light. This is a vein of magnetite, a naturally occurring magnetic iron oxide. Scientists discovered something quite startling in the late 20th century. The human brain contains millions of tiny magnetite crystals, particularly in the ethmoid bone behind the nose and within the cerebellum. This is a phenomenon known as magnetoreception. These microscopic crystals are identical to those found in the beaks of migratory birds and the bodies of sea turtles, helping them navigate the globe by sensing the Earth's magnetic field. As you lie here, your own internal compass is vibrating in subtle harmony with the very walls of this cave. You are literally tuned to the magnetic north, a silent, unseen connection that anchors you to the planet's core. Notice how the air feels slightly more humid now, a soft mist that seems to carry a heavy, comforting warmth. This moisture is part of the deep carbon cycle. While we often focus on carbon in the atmosphere, about 90% of the Earth's carbon is actually stored deep underground in the crust and mantle. What's happening now is a slow, rhythmic exchange. Carbon dioxide is pulled down into the Earth through the movement of tectonic plates, a process called subduction, where it is eventually locked into minerals like calcite or squeezed into diamonds. This process takes millions of years to complete, acting as the planet's long-term thermostat. Your own breath, containing carbon that was once part of a star, is part of this epic, slow-motion recycling program that keeps the Earth habitable for life. Consider the heat that is currently radiating into your spine from the basalt ledge. This isn't just residual warmth from the sun. It is radiogenic heat, produced by the steady, peaceful decay of long-lived radioactive isotopes like uranium-238 and thorium-232, which are distributed throughout the Earth's crust. This decay releases tiny amounts of energy that, over billions of years, have kept the interior of our planet warm. This internal furnace is what drives the movement of the continents and the growth of every crystal you see. It is a slow, steady heartbeat of energy that has been pulsing since the Earth formed 4.5 billion years ago, providing a constant, maternal warmth that cradles you in this darkness. Picture this. The very rock you are lying on is not as solid as it seems. It is teeming with a hidden form of life. Scientists have discovered endoliths, microorganisms, including bacteria and fungi, that live inside the microscopic cracks and pores of rocks, even miles below the surface. These remarkable creatures don't need sunlight to survive. Instead, they eat the minerals around them, gaining energy from the chemical bonds of iron, sulfur, and manganese. Some of these deep earth microbes have such slow metabolisms that they may only divide once every 1,000 years. They exist in a state of near-permanent meditation, a biological pace that perfectly matches the growth of the crystals. In this cavern, you are surrounded by a slow-motion biosphere, a secret world of life that is content to wait for centuries in the dark. At this very moment, your mind might wander to the technology you left behind on the surface, your phone, your computer, your watch. It is worth considering that our modern digital world is essentially built out of the minerals in this room. Every microchip is a wafer of ultra-pure silicon, refined from the very quartz you see in these walls. Quartz has the unique ability to vibrate at a precise frequency when an electric current is applied exactly 32,768 times per second. This piezoelectric pulse is what allows your devices to keep time and process information. We haven't moved away from the Stone Age. We have simply learned to make the stones think. The silence of this cavern is the same silence found at the heart of every piece of technology we own. Observe the way the minerals are organized in the wall. You might notice a layer of green, flaky mineral known as chlorite. It feels almost like dried clay or wax. Chlorite is often a secondary mineral, meaning it forms when other minerals, like pyroxene or biotite, are altered by hydrothermal fluids. Think of this as the Earth's version of a renovation. The planet is constantly breaking down old structures and using the raw materials to build something new. This is a process of pseudomorphism, where one mineral replaces another while keeping the original's outward shape. It's a reminder that change in the natural world is not a loss, but a transformation, a slow, patient reimagining of what matter can be. What's happening now, as you settle deeper into your rest, is a synchronization of timescales. On the surface, our lives are measured in seconds, minutes, and hours. But here, the standard unit of time is the galactic year, the 230 million years it takes for our solar system to orbit the center of the Milky Way. To the crystals, the rise and fall of the Himalayas is a recent event. This perspective is a gift. It allows the trivial worries of a single day to dissolve into the vast, stable history of the stone. Your body, which is composed of 65% oxygen and 10% hydrogen, is made of the very same atoms that were forged in the hearts of dying stars and then gathered here by gravity to form this planet. You are stardust that has come home to rest in the dark. At this very moment, somewhere deep below you, a pegmatite is cooling. Pegmatites are special igneous rocks where crystals can grow to truly gargantuan sizes because the magma was exceptionally rich in water and rare elements. In the Black Hills of South Dakota, a single crystal of spodumene was found that measured 42 feet long and weighed 37 tons. Imagine a crystal the size of a school bus, growing in total darkness, atom by atom, for 100,000 years. These giants are the elders of the mineral kingdom, standing as monuments to what can be achieved through nothing more than steady, undisturbed persistence. Notice the texture of the air as you inhale. It is rich in aerosols, of mineral salts. When water drips and splashes in these caverns, it creates tiny airborne particles of calcium and magnesium. Some researchers believe that breathing this mineral-rich air, a practice known as speleotherapy, can have a profound calming effect on the human respiratory system. It's as if the mountain is offering you a slow, saline mist to soothe your lungs and relax your chest. Each breath is a quiet communion with the chemistry of the deep. In this sanctuary, there is no such thing as waste. Every atom is eventually reused. When a crystal finally breaks or dissolves, its components are carried away by groundwater to become part of a new lattice elsewhere. This is the ultimate circular economy. The iron in a piece of hematite today might have been part of a volcanic plume a billion years ago, and it might become part of a deep-sea sediment a billion years from now. This continuity is the definition of peace. Nothing is ever truly lost. It is simply waiting for its next turn to be part of the geometric order. As we continue our journey, permit your consciousness to expand to the size of the cavern. You are the stillness. You are the warmth. You are the slow, rhythmic drip of the mineral-rich water. The boundaries between your skin and the basalt ledge are becoming blurred. As the heat of the earth becomes your own heat, you are participating in the long, slow life of the lithosphere. The weight of the world above is not a burden, it is a shield. It holds you in place, protecting your peace from the fleeting storms of the surface. In this place, growth is inevitable, but it is never rushed. There is time for everything. There is time for the atoms to find their rooms. There is time for the heat to decay. And there is time for you to let go of every tension, every thought, and every obligation. You are part of the mountain's memory now, a brief and beautiful spark of life resting in the eternal, crystalline dark. As you breathe out, feel the last of the surface world's urgency leaving your body. It is being replaced by the heavy, reliable density of the stone. You are safe. You are held. You are grounded in a history that began before the first breath was ever drawn, and which will continue long after the last one has faded into the silent, sparkling dark. Deep within this sanctuary of stone, your body has become a part of the local geography. The basalt ledge beneath you acts as a thermal reservoir, a dense volcanic rock that excels at storing energy. Scientists refer to this as high thermal inertia, because basalt has a specific heat capacity of about 0.84 kilojoules per kilogram per degree Celsius. It holds onto the Earth's internal warmth with incredible tenacity, releasing it slowly against your skin in a steady, unwavering flow. This is why, despite the miles of rock above us, you feel a profound sense of cozy, radiating comfort. Consider the way your eyes perceive the colors in this twilight. You might notice a vibrant, velvety green coating on some of the surrounding rocks. This is malachite, a copper carbonate hydroxide mineral. A curious thing happens with malachite. It is idiochromatic, meaning its color comes from its essential chemical composition, specifically the copper, rather than from impurities. No matter how you grind it or where you find it, it will always be that deep forest green. Contrast this with the allochromatic minerals, like the clear quartz nearby. In its pure state, quartz is colorless, but when a few atoms of aluminum are replaced and the crystal is exposed to natural gamma radiation from the surrounding granite, it transforms into a smoky, translucent gray. This chemical, Y, is the reason for the cavern's palette. It is a visual map of the elements present during the crystal's birth. At this very moment, your ears may be picking up a sound that is difficult to describe. It is a subtle, metallic tinkling, almost like distant wind chimes. What's happening now is a phenomenon called thermal contraction. As the hydrothermal fluids that filled this vug millions of years ago slowly receded, and the temperature dropped by even a fraction of a degree, the crystals underwent microscopic shifts. Because minerals like pyrite, often called fool's gold, have a very rigid cubic structure, these tiny adjustments can create audible pings. Pyrite is composed of iron and sulfur, and its atoms are arranged in a face-centered cubic lattice. If you look closely at a cube of pyrite, you will see fine, parallel lines on its faces called striations. These are not scratches, but the literal edges of atomic layers, evidence of the crystal's struggle to grow in two directions at once. Take a moment to focus on the scent of this deep environment. It is remarkably distinct from the organic, loamy smell of the surface. Here, the aroma is petrogenic. It is the scent of the elements themselves. You might detect a faint, sharp tang like a spent match. This is the presence of native sulfur, often found near volcanic vents. There is also a heavy, wet stone smell caused by geosmin. While usually produced by soil bacteria like Times Streptomyces asterisk, geosmin can also be trapped in mineral pores for thousands of years. Humans are incredibly sensitive to this scent, able to detect it at concentrations as low as 5 parts per trillion. Down here, IB, down here, that scent is a bridge to the primordial past, the smell of a world that is still in the process of being forged. Notice how the textures around you vary with such precision. Reach out in your mind and touch a cluster of dogtooth spar, a sharp, pointed variety of calcite. It feels remarkably different from the satin spar gypsum nearby, which has a fibrous, silky texture that feels almost like a spool of thread. Scientists discovered that this tactile variety is a result of the mineral's tenacity. While calcite is brittle and will shatter if struck, gypsum is sectile, meaning it can be cut with a knife like hard wax. This softness is due to the way the water molecules are integrated into the gypsum's chemical structure, acting as a lubricant between the layers of calcium and sulfate. It is a reminder that even the hard world of rock has its own internal softness and flexibility. A fascinating thing occurs within the clear quartz points that surround you. If you look deep into their centers, you might see phantom shapes faint, ghostly outlines of smaller crystals inside the larger one. These phantom crystals are records of interrupted growth. Imagine the crystal was growing steadily for 10,000 years, and then the mineral supply suddenly ran out. A layer of dust or another mineral, like green chlorite, settled on its faces. Centuries later, the mineral-rich water returned, and the quartz began to grow again, encasing the older, dusty version of itself in clear stone. It is a silent choreography of atoms, a dance that has been paused and restarted over eons, creating a three-dimensional photograph of time. Consider the physics of the light in this chamber. Even though it is dim, the crystals seem to amplify what little energy exists. This is due to their refractive index. Diamonds, for instance, have a very high refractive index of 2.417, which means they slow light down significantly, bending it and trapping it within their facets. While the quartz here has a lower index of 1.544, it still manages to catch and bounce internal reflections in a way that creates a soft, ambient glow. This light is a frozen symphony, the result of photons navigating the geometric obstacles of the atomic lattice. It creates an atmosphere of diffused, gentle illumination that doesn't strain your eyes, inviting them to close. Notice how the temperature of different stones feels against your skin. If you touch a piece of jade or quartz, it feels significantly colder than a piece of amber or jet. This isn't because they are at different temperatures. Everything in this room is at the same 25-degree equilibrium. Instead, it is due to thermal conductivity. Quartz is a very efficient conductor of heat. It whisks the warmth away from your fingertip rapidly, making it feel cold. Amber, which is fossilized tree resin, is an insulator. It refuses to take your heat, feeling warm and inviting. This sensory illusion is one of the many ways the mineral world communicates its internal structure to you. Deep within the silence, there is a rhythmic thrum that you might feel more than hear. This is the Earth's background hum, a continuous seismic oscillation that was first documented by scientists in 1998. These oscillations have periods of several minutes and are thought to be caused by the constant movement of the atmosphere and the oceans, which ring the Earth like a giant bell. Down here, in the solid crust, you are closer to the source of this vibration. It is a low-frequency pulse, a planetary that resonates with the water in your own cells. It is the most grounding sensation imaginable, a reminder that the entire world is vibrating with a slow, steady life. What is happening now in the corner of the VUG is a rare display of triboluminescence. If two pieces of quartz were to rub together due to the slow shifting of the Earth, they would produce a faint, internal flash of light. This occurs because the mechanical energy of the friction pulls electrons away from their atoms, creating a tiny burst of electricity that excites the air trapped in the crystal's cracks. It is a fire that requires no oxygen, a spark generated by the sheer will of the stone. It is one of the many secret ways the Earth illuminates itself in the places where the sun cannot reach. As you lie there, consider the liquid inclusions we mentioned earlier. Inside some of these crystals, there are tiny bubbles containing water that is millions of years old. Within those bubbles, there is often a tiny, moving bubble of gas. If you were to watch it through a microscope, you would see it dancing in a jittery, random motion. This is Brownian motion, the result of individual water molecules colliding with the gas bubble. It is a direct, visual proof of the existence of atoms, a microscopic ballet that has been performing inside that crystal for 10 million years without ever stopping for a single second. The air you are breathing is part of this ancient system. It is heavy with the aerosolized essence of the mountain. In the stillness, the humidity remains at a constant 90 to 100%, which means your skin doesn't have to work to retain its moisture. You are in a state of hydrostatic equilibrium. Your lungs are relaxed, your heart is steady, and your mind is becoming as clear and orderly as the quartz lattice. Observe the way the minerals are layered on the floor, a sequence known as a paragenetic sequence. First, the dark sulfides were deposited, then the translucent quartz, and finally the soft, white calcites. It is a geological to-do list, a record of the changing chemistry of the Earth's deep fluids. It shows us that there is a time and a place for everything. A time to be hard and dark, and a time to be light and clear. As you prepare for the final stage of this journey, allow your senses to fully merge with the environment. The scent of sulfur and wet stone, the tinkling of contracting crystals, the warmth of the basalt, and the deep, seismic hum of the planet are all weaving together into a single tapestry of rest. You are no longer an observer. You are a participant in the slow-motion architecture of the world. Your breath is the wind in the cavern. Your heartbeat is the pulse of the magma, and your consciousness is the clear, silent light reflecting off the faces of 1,000 ancient gems. Sink further into the darkness. Let the weight of the mountain be your protector. The world above is far away, its noise filtered through miles of solid, silent stone. Here, in the heart of the crystal, there is only order, only warmth, and only the endless, beautiful now. The story of the Earth is a story of patience, and you have finally learned its most important lesson: how to simply be. The journey through the deep reaches of the Earth is drawing to a close, much like the slow, inevitable cooling of a magma chamber. As you lie there on the warm basalt, feel the transition from movement to stillness. We are entering the final stage of the crystal's life, the stage of equilibrium. In this phase, the growth has reached a point of perfect balance. The atoms are no longer rushing to find their places. They are settled, locked into a geometric embrace that will last for millions of years. What's happening now is a process scientists call diffusion-limited growth. This occurs when the mineral-rich fluids in the cavern have been mostly depleted. The few remaining atoms of silica or calcium must travel long distances through the stagnant water to find a place on the crystal lattice. Because this happens so slowly, the crystal grows with an almost supernatural precision. It is a step-by-step unfolding that mirrors the way your mind is now beginning to let go of the day. Consider the very first step in the life of the crystal you've been observing: nucleation. It began with a supersaturated solution. This is a state where the water holds more dissolved minerals than it normally could, often because of extreme pressure or heat. To start the process, a single seed was needed, perhaps a microscopic grain of sand or a tiny bump on the cave wall. Once that first atom locked into place, the enthalpy of crystallization was released. This is a tiny burst of heat energy that occurs whenever a chemical bond is formed. It is the Earth's own way of saying, "This is where the structure begins." Notice how your breath has found its own nucleation point, a steady, rhythmic center around which your entire body is now organizing itself. Just as the crystal builds itself atom by atom, your rest is building itself breath by breath. As the crystal grows, it must follow one of the 7 crystal systems defined by symmetry. These are the blueprints of the mineral world: isometric, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, and trigonal. In the case of the quartz points above you, they follow the trigonal system, which dictates that they must always grow with 6-sided symmetry. This isn't a choice, it is a fundamental law of the universe. Within this law, there is a profound peace. There is no struggle for identity, there is only the manifestation of an inherent, perfect design. Picture this process happening in ultra-slow motion. A single ion of silicon, carrying a tiny electric charge, drifts through the dark water. It is pulled by the electromagnetic attraction of the existing crystal face. It doesn't land randomly. It skates across the surface until it finds a kink site, a specific, unfinished corner in the lattice. Once it fits into that corner, it is held by 3 or 4 bonds instead of just one. It is home. It is secure. It is exactly where it belongs. Scientists have discovered that, as these crystals reach their final size, they often undergo zoning. If you were to cut a crystal in half, you might see concentric rings, much like the growth rings in a tree. These zones are a step-by-step diary of the Earth's internal weather. A darker band might indicate a century where the hydrothermal fluids were rich in iron. A clearer band might represent 1,000 years of pure, undisturbed silica. This zoning is a reminder that even in the most perfect structures, there is a history of change, all held within a final, peaceful form. As your body sinks deeper into the basalt, consider the process of biomineralization that we touched on earlier. Within your own brain, the pineal gland responsible for your sleep-wake cycle actually contains microscopic calcite microcrystals. These tiny structures, often less than 20 micrometers in size, are made of calcium carbonate. While their exact function is still being studied, some researchers believe they may play a role in how your brain processes electromagnetic signals and regulates the production of melatonin. As the light fades in your mind, these tiny crystals are part of the internal machinery that is signaling to every cell in your body that it is time to rest. The temperature in our cavern is now perfectly stable. This is the isothermal stage. In large, intrusive igneous formations, like the granite batholiths that form the cores of mountain ranges, the cooling process can be incredibly gradual. A massive body of magma can take over 1 million years to cool by just a few hundred degrees. This Extreme stability is the secret to the most beautiful gems. Because the temperature doesn't fluctuate, the atoms have all the time they need to find their perfect positions. There are no dislocations, the scientific term for mistakes in the crystal lattice. Notice the dislocations of your own day, the hurried thoughts, the unfinished tasks, the minor stresses. In this isothermal environment, those mistakes are being smoothed over. You are allowing your internal temperature to stabilize. You are giving yourself the millions of years of geological time necessary to reach a state of perfect, crystalline order. The sound of the cavern has changed. The drip, drip, drip of the mineral-rich water is slowing down. The vug is finally sealing itself off from the rest of the world. In the life cycle of a geode, this is the moment of completion. The outer rind of chalcedony has become thick enough to be impermeable. The water inside is now trapped, a permanent internal sea. Within this sealed chamber, the pressure and the chemistry will remain unchanged for eons. It is the ultimate sanctuary. You are now in your own sealed sanctuary. The noise of the surface world cannot penetrate the miles of stone above you. The air is still. The warmth is constant. The geometric order of the crystals is your only company. You are a part of the Earth's long-term memory, a stable and beautiful fragment of the universe. As we transition from the world of the mountain to the world of your dreams, feel the heavy, grounding energy of the stone becoming the weight of your own limbs. The minerals in your bones, the hydroxyapatite, are vibrating in harmony with the quartz and the calcite. You are grounded. You are supported. You are solid. Let these affirmations drift through your mind like the tiny ions in the cavern water, finding their place in your internal lattice. I am as stable and enduring as the ancient stone. My breath is the slow, rhythmic heartbeat of the planet. I am grounded by the constant, gentle pull of the earth. Like a crystal, I am finding my perfect, orderly center. The pressure of the world only serves to strengthen my spirit. I am a witness to the beauty of time and the wisdom of silence. My rest is deep, solid, and undisturbed. I am composed of the same stars and minerals as the mountains. I release the urgency of the surface for the peace of the deep. Every cell in my body is vibrating at the frequency of the earth. I am safe within the warm, velvet darkness of the earth's embrace. My mind is becoming as clear and tranquil as a quartz point. I have all the time I need to grow and to heal. The stillness of the cavern is my own internal stillness. I am an essential part of the Earth's magnificent design. I am resting in the heart of the world. The glow of the fluorite is fading. The hum of the earth is becoming a soft, distant lullaby. The crystals have finished their work for today, and so have you. The atoms have found their homes. The lattice is complete. The warmth of the basalt is a final, gentle hug as you drift across the threshold into sleep. In this place, there is no time. There is only the beautiful, dark eternity of the stone. There is only the purity of the mineral world. There is only the deep, heavy peace that comes from knowing you are exactly where you are meant to be. The journey is complete. The mountain is silent. The crystals are still. You are home. Good night.